Yeah, so I can introduce myself for everybody else, unless you'd rather me wait for like the beginning of the community meeting.
No,
How
go
you
for it,
guys?
Brooks.
Yeah, so you know, as Kate mentioned, we worked together a lot during undergrad. I have been at Capital One for the last 2.5-ish years, and while I was there, I started working on an open source project called Wasm Cloud, which was pretty intimately working together with like some of the people on the Crustlet team. At one point, we had Wasm Cloud support in Crustlet as one of like the runtimes, so we worked together often with that. And I just recently left Capital One to work at Cosmonic, which is like we're building a company around making like an enterprise offering of Wasm Cloud. So uh, yeah, I'm excited to work on that stuff full time. And I've been meaning to come to one of these meetings for a long time. It just for whatever reason didn't jive with my schedule, but things are a lot more free now that I'm in the startup life and not a 50,000 person company. So happy to be here.
Welcome to the call and to the
Yeah.
Akri community.
And that's great that it's less hectic now.
Yeah. Well,
I guess,
less filler meetings, more exciting things.
hey, that's good to hear. I guess we can all go around and introduce ourselves then as well. So I'm Kate. I work here at Microsoft, and I am a maintainer and a core developer for Akri. Yeah, and I'll pass it off to Roa.
Hi, I'm Roa. I'm a developer at Microsoft too. I work on other Kubernetes related projects and also helping out as a maintainer for Akri. So pass it to Brian.
Hi, I'm Brian. I feel like we're all going to say roughly the same thing. I essentially doing what Ro's doing. I've been working with Akri for a while and other Kubernetes ventures. I work at Microsoft. Edric?
Hi, yeah, I'm Edric. I'm the PM on Akri. I'll pass it over to Vincent.
Hi everyone. Hi, I'm Vincent. I'm a developer at Microsoft, and I've been working on Kubernetes related projects and helping out Akri.
Awesome. Well, that was a good go round. I think we can go ahead and get started with the agenda. I'll share it, my screen right now to bring it up. Maybe. One second. I need a claim host. We love this part of this. Anyone know who has host? Oh, wait, here, I can do it. One sec. Okay, great. Awesome. Okay, so to start off the meeting, just an announcement. KubeCon proposals are due by December 17th. So if anyone has any ideas on what would be interesting for Akri to present there, we've had some discussions with the Kubernetes IoT Edge working group about potentially creating a panel on the IoT space for Kubernetes. It'd be great to have customer perspectives on that and then also developer perspectives. So if anyone has any people who they think would be interested in being on a panel like that, or any ideas of kind of the questions that would be involved in a panel like that, that would be great. Feel free to ping someone, one of us on this call, or drop it in the Akri chat or in the IoT Edge working group, Kubernetes Slack. Hopefully we'll put together something for that. And then beyond that, if people have other ideas on what they would like to see from a proposal for Akri, more than happy to talk about that. Any ideas currently from anyone on this call that they want to bring up? Cool. So the first on the agenda is from Vince. Do you want to kind of give us an overview of the PR you just merged that kind of changes our workflows on how to kick off some of our tests?
Yeah. So for this change, the behavior previously, the workflow is a developer can create PR and they can add some flag onto a title. And the flag will indicate the workflow to run some of the build process or to run some of the check version procedure. And the problem with this is so the check, if they want to run some workflow again, they would have to, a developer would have to push a new commit in order to trigger the check for the flag in the title, in the PR title, to run the workflow again. And we want to remove that inconvenient process of having to push a new commit. So we are moving forward, we will have the workflow trigger by label in the PR. So a developer can create a PR and they can add a label that say, I want to run this workflow and I want to run this workflow. And the GitHub workflow will check the label in order to execute the right workflow.
Awesome, thanks, Vince. Yeah, I think this makes our PRs a lot cleaner in the cases where you don't want to check the version. For example, say you didn't make a major change. Maybe it was just some README change or something small, or I guess something that you don't want that same version check to be kicked off. It's great to just be able, now you can comment to add the label, and it was a really awesome ad that Vince did. So super excited to see that in. And Vince also put in the supporting documentation into our documentation site. So that is ready to be used. So before we jump into the next two ones, which are kind of heavy, are there any other agenda items people want to add or anything people want to talk about? Cool. So the past few months, I've been looking at how can we expand the scenarios of Akri. So currently, we kind of have one use case or one major scenario that you can use Akri for. So you can use, what Akri does is not only discovery, but it is an interface for easing the use of devices as well. And so after our agent discovers your devices, our controller can automate the deployment of pods to use those devices. What that deployment looks like is one specific scenario. So for every device that Akri discovers, our controller will deploy a pod to each node that can see that device. So it's a very microservice approach. So you can imagine, say you had 2 IP cameras on your network and 2 nodes. After the agent discovers those, the controller would deploy a broker to each node for each camera. So you would end up with 2 pods on each node using those cameras. And so this creates a scenario of high availability so that you can say one node were to go down, you still have the other node processing those cameras the whole time. However, some people may not want high availability, or more so, you may not want those pods to run all the time. So we have this assumption that these pods never come down. So they're always brokering some information or always interacting with those devices. However, there are plenty of IoT scenarios that may not fit these cases. So these 2 proposals kind of discuss how we can go about looking into other options for that. And so the first one is a proposal for supporting terminating pods. So say you want to discover a device and then have some workload deployed to it that terminates. So maybe it's some kind of management workload. So for that IP camera scenario, maybe it does a firmware update of the IP camera. For other scenarios, maybe you just want to quickly deploy a workload that sees that device and adds it to some inventory. Or maybe it's some other management event, like you're changing some settings on a device. These are all cases where you would want Akri to deploy a pod and let it terminate. And currently what we do is we redeploy it because we have this expectation that those pods should always be running. So I created a proposal to discuss what adding terminating pods would look like. Just to kind of, instead of like going through all of the text here, I'll kind of go through sections of it. If people have questions or things that they want to highlight, please interject. But the background section kind of talks about what I just mentioned, and then takes us to the discussion of how should we support terminating pods. And that was a slip there because it seems that the best way to do it would be to use jobs. So in Kubernetes, jobs is a higher level object that basically manages the deployment of pods that are allowed to terminate. So within a job is a pod spec, but there's also other fields, like you can specify how many replicas or how many times you should allow it to retry upon failure. So instead of our controller mimicking all of that work and having to implement that retry failure, instead, this proposes adding the option to add a job spec to our configuration to specify what should be deployed to discovered devices. So one reason why, yeah, so that's a little bit on that. What would entail, this implementation would entail is changes to our configuration custom resource definition. So that's where you tell Akri what you want to find by specifying a discovery handler and what you want deployed to what Akri finds, which is currently just a pod spec. So it would be expanding that to be a larger enum. Proposed name is broker type, and within that, it's either a pod spec or a job spec. And then you would need to add logic to the controller to deploy these jobs upon device discovery, and logic to the agent to allow for multiple jobs, to allow for configurations to be updated, because say you may want to redeploy a job. So looking at that a little bit more in detail, this is our configuration custom resource definition. As I mentioned, it consists of the discovery handler, which is where you say what you want to find. And then it consists currently of a broker pod spec. You can also specify instance level services. So that's a service that's created for every single discovered device, and configuration level services, which is a service created for all devices of a type or of a configuration. So those provide stable endpoints for accessing either a specific device or a set of devices. And then we have broker properties, which is where you can specify environment variables that are injected into workloads that are deployed, and capacity, which is how you can specify the maximum number of workloads that can use a device at once. So say you don't want to overload a device, that will control how many pods can use a device at once. So that's a refresher of our current CRD, and here's it in the great YAML form. And then breaking into the proposed edition, all it is expanding what was a broker pod spec to being a broker type, and you can also add a broker job spec. One note here that I make is we may want to move away from broker terminology. This is something that we had from the start with Akri. We call that workload, that pod that we deploy to every device, a broker, because we had originally we were thinking about Akri being useful for scenarios such as protocol translation gateways, where you may discover an IP camera or discover a USB camera and deploy some broker that advertises it as an IP camera. Or in general, the idea of that workload brokering some information from that device. With jobs, that's not really what it's doing oftentimes. So this is kind of a call to open up some brainstorming for figuring out what we want to call that. We could use the term workload is one initial idea, but any ideas on that would be great. I'm going to pause here. are there any questions around why we're supporting terminating pods, why we're using jobs, why we are adding, or why we're proposing to add it to the configuration in this form? Any questions along that or any others? Cool. Any initial thoughts on renaming broker to something else?
I think it sounds like a good idea to contemplate a more inclusive terminology. I certainly think broker was an initial thought, but I think it's almost restrictive at this point, considering we're opening up different deployment methodologies. And so I think workload makes a lot of sense.
Yeah, I think workload is what I like to use, but I'm wondering if there's maybe even something else. Yeah, I can't think of any at the moment, but I guess the one thing is whether we want to move to new terminology now by saying something like workload type, or if we are okay sticking to broker for now and making that a whole nother discussion, which is probably the more ideal approach for the time being. So moving a little bit into kind of what this implementation entails. So currently the way that Akri works is you have our agent, which is watching for configurations. And when it sees a configuration, it will it will discover those devices using a discovery handler and create device plugins to represent them. And then our second custom resource, instances, to represent them and their use. Then our controller is watching instances. So upon instance creation, our controller then will deploy pods to use those devices if any broker is requested. So this implementation proposes expanding, so digging a little bit more into that controller design. So the controller has an instance watcher. Every time it sees an instance, it'll deploy a pod to each node that can see that instance. It will then remove those pods when that instance goes away. And then it has a pod watcher that will ensure that those services are running when those pods are created. And then we have a node watcher that will basically handle if a node in the cluster disappears, making sure that the instance is updated to show that that node can no longer see that device. This new design, I highlighted everything in blue. I think I'm going to shade this instead of outline. But what it adds is a configuration watcher to the controller as well. So that, and the point of the configuration watcher is mainly because with jobs, it seems, and this may be an assumption, and so this is where it'd be great to hear other people's thoughts, that it would be useful to have scenarios where you may want to redeploy the same job. So say you have some update or management job. Let's say it's a management job that, or say it's an update job that like updates the firmware of some device. Maybe you deployed it like a few months ago and you want to redeploy it. You may not want to, currently what Akri does when a configuration is updated is the agent sees that, and instead of gracefully handling it, it just deletes the previous configuration. So that'll delete all the instances, all the device plugins, and creates another one. And so it's kind of like a restart. What may be better is to do some more graceful handling of configuration changes. And so in order to do that, the controller also needs to be watching the configuration and keeping track of state. And so this proposes adding like a map of all the applied configurations to the controller and also a watcher, so that when a configuration is applied, if it is a modified event, it'll check and see, has the broker type that section of the configuration updated? If so, let's bring everything down and then bring everything back up. So this could be that could be a full-on change of what that job looks like. Or it could be maybe you rename that, do a small change, like a rename of that container to trigger a restart of those workflows. But it's basically a way to change your deployment, whether that be pods that terminate or not, without getting rid of instances and device plugins. Are there any thoughts on that? So it adds a little bit more overhead to the controller by adding that map of the configurations and also that watcher, but it does enable more graceful handling of configuration changes so that you can redeploy or change what is deployed to devices. Cool. I'm gonna take either the no thoughts there as still processing it, or the thumbs up, but feel free to chime in if any direct thoughts on that. Also in the controller, what's changed is when an instance is added, there's just a check on what type it is, what type of broker is that configuration that owns that instance, and then it'll deploy a job, a single job to the device if it's a job, and otherwise it'll deploy a pod in the previous method of on each node that can see it. So that's an important note. So just as we have one strategy for pods, this adds one strategy for jobs, and that is we will deploy a single job to that device on the cluster. So just whatever job spec you specify, we will deploy to each discovered device. Instead of with pods, we made it so that we would deploy one to each node. It's just a single one. And that's the assumption that if you have a job that you're deploying to a device, you probably don't need it to run in multiple places. Yeah, Rowan?
So actually a couple questions. So what happens if you have multiple jobs? Does the controller take care of only deploying one at a time, or does it like leave that on Kubernetes and kind of schedule them all, and then it will determine whether the resource is available or not?
By multiple jobs, do you mean, do we support specifying multiple job specs in our configuration?
Yeah, like this is one way, right? You can specify multiple jobs if we support that. And the other one is you apply multiple configurations with different jobs, and each of those kind of use the same resource.
Yeah, okay. So our configuration, the design currently only supports one job. Say you want replicas, that's a specification within the job spec. So it's a normal standard Kubernetes job spec. So you can specify like 3 replicas if you want 3 replicas of that job or that pod that's specified running. That is, you can do that just within the job spec itself. What we don't support currently is making it so that you can use the same instances from 2 configurations. So a configuration fits a scenario is kind of our assumption so far. So a configuration you discover and use the device. If you deploy another configuration, it may have the same discovery handler. So it may discover the same sets of devices, but it will create new instances. So you can keep deploying those. We actually have a bug right now that is making that not possible, but you should be able to do that once that's fixed. But in the same configuration currently, you can't deploy multiple jobs. You can't specify multiple job specs.
Yeah, but even for the other scenario, assuming that bug is fixed, we know it's NPR. Like, how can we coordinate multiple jobs to the same resource, even if they're using different instances or configuration? Let's say one job is updating the firmware on the camera, like that would like kind of conflict with the other job that's trying to, maybe update something else, the frame rate or something, some other configuration.
Yeah, I think that's a good point. Like, should we add preference or priority somehow and make it so that the controller can know which configuration should have priority, things like that. That is not a part of this design. I think the one way you could do it with this design is you could set capacity to 1. And so that's how we limit the number of pods that can use a device. So if you set, yeah, but then again, if you set capacity to 1 in each configuration, that's still a problem. So I think that's a good point. I think one ideal solution to this that I've been thinking about is we should possibly break our configuration up into 2 components, the discovery component and the use component, so that you can deploy a discovery configuration and then several use configurations. And in that discovery configuration, you could set your capacity. So you could set capacity 1, and then in your use configurations, you can deploy as many use configurations as you want, specifying as many jobs as you want, but capacity is still 1. And so only 1 would be able to be running at a time, I think is one way we could handle that. Do you have any thoughts around how we might manage that?
Yeah, I think what you mentioned kind of makes sense, like splitting out and being able to control this other part independently. It's what I had in kind of mind. So yeah, but yeah, thanks, Kate. Also, I have a kind of it wouldn't be a question, but I actually don't know like how most of the community is using jobs right now. Like, for example, there are some features where like jobs will automatically be removed once your job is complete, or like retaining X amount of jobs after completion. Because I noticed that when we're doing like, it seems like the current, like, are we leaving this up to kind of the user to determine, I guess, or would Akri be a little bit more opinionated about what we do with jobs once they're completed?
Yeah, so you're saying once the jobs run and it's in that completed state, are we cleaning those up? Or are we leaving them? Is that the question?
Yeah, it seems we remove them like the next time the configuration is changed, but I don't know if we want to like remove them once it's completed and if that's kind of the common usage people are used to outside.
Yeah. I think that's a good question. I think that's something where we should poll people and we can easily modify how we handle that, I would think. I've started with this implementation and right now we leave them. So they're just in that completed state. I think that's useful because you can look at the logs then. You can look at the logs of the deleted ones too, probably using like a previous command with kubectl, but like I think leaving them just also shows what executed. But I think that's a good question to pose. But I think also yeah. And going back to what you were saying about breaking up the configuration, in the second proposal that's PR'd into the doc site, there's a section on what that would mean and what that would look like. Yeah, people can check that out too. And maybe we even break that into a separate proposal as well. I think not all these proposals, once merged, are they going to be pursued right away, like implementation wise, but at least it would be something that we could point people to for a discussion and have people extend as well. Okay, so with this, the proposed implementation, the pod state watcher doesn't change at all. Or sorry, the instance, sorry, the pod state The only thing that's changed is when a pod is created, when a pod ends, there's a check that says, is this owned by an instance? So within Kubernetes, there's owner references. And if something is, when you deploy a job, all those pods are owned by the job. However, with our controller, all of the pods we create are owned by our controller or our instances. And so there's just a check there to see if it's instance owned, then we just don't do anything. This is the coloring is reverse on this. That was confusing me. I need to fix that. But if it's owned by an instance, we don't do anything because it completed and we're good and done with it. If it, I don't know if I said that right. If it's not instance owned, we don't do anything. If it is instance owned, like what was our previous scenario, then we continue with our previous scenario, which is confusingly blue here, and redeploy the pod because we expect it not to terminate. And then nothing in node state has, will change. Are there any other questions here? Okay. So kind of I break down some of this implementation steps here. And then I also bring up a question of, with jobs, it also seems like it may be interesting to communicate with the jobs to hear about the result of their work. For example, say after you do some kind of management activity, maybe you want to report back to the agent or somehow reflect in the instance CRD some output information. So maybe you want to report the firmware that you just updated the device to. So I kind of put in a paragraph discussing what would it look like to have bidirectional communication between the agent and the broker pods. So currently you can think that we have one directional communication because when by creating device plugins, we're effectively setting environment variables in our brokers. So with all the connectivity information for that device. So for example, for an IP camera, the RTSP URL for a device is mounted or set as an environment variable in a broker. And so that's one way that the agent is effectively communicating to the broker. And the question would be, should the broker somehow be able to communicate back? What would that look like? Should that be like a file watcher, gRPC interface? Is that not necessary? Is that too much to ask of Akri? But kind of a discussion around that I wanted to put in. Any thoughts on any of that? Cool. Well, if there's no other thoughts on this, I can go ahead and show y'all what I have just to kind of put a picture together of what brokers' jobs would look like. And yeah, that sounds good. Great. Okay. So because I was working on this or still developing it, I'm running everything locally. Nothing's in a container. But you can see that I'm just gonna start the controller and agent. And then we'll look at my cluster in a second. So this is my cluster here, or this is the interface we're going to be using. And just to show, this is the configuration we're going to deploy. So you can see it has this new broker type in it, and we're specifying that we're going to deploy a job, and then here's that job spec. So within a job spec is a template, and inside the template is a pod spec. So this is our pod spec here. And just one other thing that a job spec has is you can specify a back off limit, a restart policy. So these are things that come with a job spec. So I specified a few of them. And this is a short-lived pod that executes and terminates. And you'll see that we're on the discovery side, we're using the debug echo discovery handler. That is our one for demo purposes. It basically will discover whatever devices are listed in the description. So by default, this is going to discover 2 devices, one fee device, fee 0 device, and one fee 1 device. And so we should expect 2 instances to be created to represent those 2 devices, and the controller to deploy a job, that job exactly, to each of the discovered devices. Any questions before I go ahead and apply that? Cool. And we normally, let's just make sure nothing's running actually. Cool. Yeah, so we don't have any pods, job services, nothing like that yet. So cool. Let's do it this way. All right, so let's look. We can see that the controllers created 2 jobs, and each one of those jobs had a pod, and so those pods are running, and then they completed. And I don't know if you all saw it, but briefly we saw a few services pop up and they went away. And so you could see that in this configuration, I still specified services. I'm not sure if services are ever going to be useful for jobs. It seems like they're usually taking an action rather than serving some information short-term over a service, but it plugged right into what we had. And so you can use services in jobs. So you may have seen them pop up briefly, but we can go ahead and rerun it so that we can look at that again. So if I change something in the broker pod, in the broker type, say we change the name of a container, the controller will notice that and it will redeploy everything. So do that. And we can see that the instances still existed, but now the pods were rerun, and you can see the services existed for a second and then they went away and they're all completed. And just as always, if you want to clean everything up, you can just delete. So and everything's gone. So that's jobs. So that matches the proposed design that we went through, but definitely happy to change things up. And yeah, would love to, if people have thoughts, put it in the proposal, or obviously we can talk more about it here. But I think this does push Akri to scenarios where people can do some more short-term things and don't have to have pods running on every node. And it didn't add too much. Any last thoughts here? Any thoughts on this process of, or I don't know, was Brian, were you about to unmute?
Yeah, I was just going to say that was awesome. Thanks for kind of running through a demo of it.
Yeah, and I think it, and I don't know, I kind of want to play with this now, but like what happens if we add like parallelism here? I actually haven't played around with that. I think I'm kind of curious actually, to kind of go with how you could create more pods to be created. But I think there'll be some fun scenarios that I think we'll hit a lot of scenarios even just with this, but even more as we look at the other proposal. Do people have thoughts in general around like the proposal process for Akri? I think it's something that we don't really have defined, but it seems like a really good way to get feedback, document, and get some more diagrams out there. I think Akri doesn't necessarily have as many diagrams of our systems. And so one thing that this added is some flow diagrams of our controller, which hadn't really been out there for people to see yet. Cool. So we have 20 minutes. I think we can discuss the next proposal, maybe a little bit, but don't want to overload too much information. And then maybe we'll stop with like 5 minutes left, 5 to 8 minutes left, and look at triage. I think we only have like one thing to triage, so we don't need a lot of time with it, but that'll give us some more time just to conclude as well. So what this spec does is it builds off of the job proposal, and it talks about even more strategies. So it discusses what a strategy is basically what do we deploy to what discovered devices, where, and how many of them. So it's that those permutations of those choices. So how many workloads are deployed to use how many devices on which nodes. And currently, like I was mentioning, we have only one scenario for pods, and that is one workload that can use a single device and it's deployed to every node that can see it. There are scenarios where, say, for example, you want to deploy one pod to use 3 IP cameras and a GPU. We can't support that currently, but that's a strategy that would be great to support. Or a scenario of using one and then deploying that maybe just to 2 of the nodes or something. So things like that we should maybe consider. So I have some definitions of things here too. But one way and to talk about some example scenarios, I think we went over a lot of them. How we currently support kind of message brokering, how with jobs, we can support these scenarios, but how we can't support some of these scenarios. So one of the things that Roa mentioned is using multiple configurations pointing to the same device. So maybe having a broker use a broker using more than one device of the configuration. Oh wait, that's not exactly related, but that is also a scenario this spec discusses. But also using more than one device of a configuration, using devices of multiple configurations, deploying only a certain number of brokers, not more of the daemon set approach we have to every node, deploying multiple of the same brokers to the same node. So maybe you want high availability within the node. That's another option. And then the final one, which is also a larger category that could be broken up into its own proposal, is being able to request a certain quantity of a type of device rather than having to request specific devices. So this is something that people have been interested in, but currently with Akri, the device plugins that we create, which make those requestable Kubernetes resources, are on the instance level. So every instance gets its own device plugin. So what that looks like is, say it's an IP camera, it may be Akri onVIF hyphen and then some hash to represent that device. And so you could request that specific camera, but what you cannot do is you can't request 3 IP cameras that were discovered by Akri. And so this kind of, this proposal discusses enabling configuration level resources. So if we were to jump down to that section, sorry if I'm making people dizzy. That's not going to help. Yeah, okay. So for example, this is what I was saying. You currently could request this resource and this resource, but previously you couldn't make a request like this. And this proposes creating a device plugin for every configuration. So that would enable requesting an IP camera in general. And then you wouldn't even need to use Akri's controller if you didn't want to. You could just create your own daemon set and request those resources, and your deployments would be made and those resources would be used. So you could still use Akri for the discovery and device plugin creation component, but then use our controller, or sorry, then use your own daemon sets and deployments to use those configuration level resources. So this really makes it easier to then also select combinations of devices. So you can more easily request one IP camera and two USB cameras and stuff like that. So it makes it not only easier for the user without the controller, but also it makes it easier for the controller as well. Because what happens then is when you request that resource, the work of scheduling where that workload is run is offloaded to the Kubernetes scheduler instead of to the controller, since you're using a higher level object, in this case, a daemon set, it could be a deployment. So that was kind of a big jump into that. But one thing that this spec discusses is these configuration level resources, and how it enables the controller to also use higher level resources. In particular, this spec proposes that the controller can create deployments instead of creating individual pods. So then the controller could specify pod affinity if you only wanted one pod on each node, but it wouldn't need to specifically only deploy a pod to each node and watch each of those pods. It can let the Kubernetes higher level object controllers handle all of that. So it really simplifies the work of the controller. Are there any questions on that? Cool. So I'm just going to take a couple more minutes here because there is so much content here. I don't want to throw it all out there, but what this proposal does show is kind of every single possible deployment I could think of with the permutations of the choices of are you using every discovered devices or only a certain number of discovered devices? And are you running, how many pods are you running on each node that can see it? Just to kind of show all the different ways you could deploy something to discovered devices. And this is not to show that we want to support this all. This is just to show what could be done and kind of hear people's thoughts on, well, which ones of these should support. I propose my opinion, which is we should only support these last scenarios because there's a certain level of high availability which just seems unnecessary, such as like multiple duplicates on the node itself and across the cluster. But that's definitely for others to add their opinion into. And I also create a similar matrix for jobs. Then I discuss how the CRD would be expanded. It's pretty much similar to the, it builds off of what the jobs one says, but then also talks about a distribution type property where you can specify how many are being deployed in your cluster and or whether it should be on every node. And that's kind of, that would change what that deployment that the controller would create would look like. And then you can specify what resources. So is it just the resources discovered by this configuration, or are you also referencing resources of other configurations? And then I kind of describe that more in detail. And then this is what we discussed. This kind of begs the question of, should we split the CRD in two, or the configuration CRD in two? If we're having a discovery point part of it and a use part of it, should those just be separate configurations? And discusses what that would look like and how it would ease some of these scenarios. The instance CRD, if multiple configurations can use it, then it's going to need something to track what configurations are using it. And so that's where this configuration deployment statuses field comes in. So what's the names of the configurations that are using this, and what's the status of their deployments? Are they completed? Are they running? Are they active? So it's a way for, say you're looking at your instances as an inventory of your devices and their use, you can really see what's using it and how's it doing. And then it discusses the implementation. So how would the agent need to be extended to support configuration level resources? And what would the controllers, this is the current design, and how would the controller need to be redesigned? And I'm not going to dig too much into that right now, But then it talks about how we can support this in kind of a phased approach. So like after we support jobs, what would each phase of this look like? And so that we can gradually add these features. And then I discuss how if we do use create deployments and offload scheduling to the Kubernetes scheduler, what will happen more often is we will have more pending pods. And that's because if you schedule a pod to a node that doesn't have resources available for it, namely it doesn't have those devices available because it doesn't have those devices available, maybe because capacity has already been filled, for example, or maybe those resources haven't even been discovered yet, you're going to have pending pods. And that can look a little cluttered. And so I just wanted to show how already today in Akri you can get pending pods, but what that looks like, and if that really was a pain point, we could add some more watching and state into the controller to kind of see if resources are available before creating deployments. But it is something that may be a side effect of this support. Are there any questions on any of this? That's certainly a lot. Hopefully this at least provides somewhat an overview for people who do want to dive into this proposal.
That's a mouthful of stuff right there. You really outdid yourself in creating some pretty descriptive specs here. I hope everyone gets the chance to take a look, and I appreciate your thoughts here. I think they're really good and moves Akri in a great direction.
Cool. Thanks, Brian. I think with that, we can move on to triage. One thing that we were thinking about maybe doing in this meeting was talking about some best practices for signing commits, because we had some, we switched to using a developer certificate of origin, or a DCO, to verify commit signing now that we're part of the CNCF. But it can be a little tricky to get used to that. And so I was going to show some ways to kind of figure out how to handle some commits not being signed within commits that are signed. But I think we might need to put that off to the next meeting, and just for the time being, kind of within PRs, discuss that. So with that, Roa, do you want to do issue triage for the last few minutes?
Sure. Can I share screen? Give me superpowers, Kate?
Yes, I will do that. Awesome. You should have it.
Okay. Can you guys see my screen?
Yes, we can.
Okay, awesome. So looking at the issues, you're totally correct, Kate. We have only one issue here that Kate mentioned. This issue is about not being able to apply multiple configurations using the same discovery handler. So Kate already has a PR with that. So I'm gonna move this to in progress, right? And is it already assigned to you? Let's see. I'll put it to you, Kate. Okay, cool. Do you think, I so many, sorry, I accidentally closed the issue. Okay, we'll do that again.
That's okay.
Okay. Do you think we have a few more minutes? We can look at if we have any new stale issues.
Sure.
So let's go look at issues, and so for stale issues, yeah, those are sorted by, let me open the last 3 ones to see if how recently were they updated.
And it looks like you have both issues and PRs, but that's great.
Yes. So this one, it's about the co-op discovery handler that Giovanni started. Okay. Oh wow, that's a lot of activity on this PR. So looks like this was marked as still 8 days ago. The last comment we have from Giovanni was, summer vacation is done. So it would gonna take a lot for him to come back. So keep it at still until he comes back or somebody picks it up. Sounds good.
Yeah, maybe we can just add a comment here asking, hey, like, need any support here with this? Maybe it's winter vacation. It would be great to get this in. But there have been a lot of changes in the meantime, so there might be some work to rebase and get things.
Yeah, I'm thinking that he'll probably need help there. Okay, I'll leave him a comment. I think we're running out of time. I can do that after the meeting. So look at this. So it's been marked at stale 15 days ago. So this is about simplifying optimized builds, make files and workflows. Brian, do you think that still applies? I know you've done some work on that in the past.
Frankly, yes. The make files, I think, aren't great. Workflows are complicated and hard, but I can't think of, I don't know, if we let this go and it disappeared, I think, that's life. I can't think of like when we're going to prioritize doing the work, or if we have the expertise to make files better or all that stuff.
Yeah, I'm trying to think if there is like maybe a more granular detail of what this actually mean, and then maybe you can add like a keep alive to that and keep it around for somebody to pick it up. Do you think you can add a little bit more details, or maybe it's there?
And just assume let it die, and if somebody has an idea for how to fix it, then they can bring it back alive with that.
Yeah, I think this could be broken into two good first issues. One would be like clean up and make beautiful our make files, and the second would be the same for workflows, and then we can add some pointers on why we think they're gross. But unless we did that, I think it's fair to let this close. And if someone's working with them and notices how they can make it better, hopefully they'll bring that forward.
Okay, sounds good to me. We'll keep it as is then. This one, I believe this was marked as still a long time ago.
I think this one can close. I don't know if we want to have multiple installation support anyways.
It will automatically close in a couple of weeks, I hope. So yeah, I think that's it. Then probably that was like the only two issues that were recently updated. With that, I think we're done with the issue triage.
Cool. And we've pretty much hit the hour. So our next meeting will be on the following Tuesday. By that point, we may have job support in. If you're watching this back, feel free to add any comments on that proposal to kind of shape that direction. And maybe we'll discuss a little bit more about those multiple deployment strategies. But other than that, this has been great. So I think we can all sign off. Thanks everyone for coming.
Thanks everyone.
Thanks.